Hi, let's look into some of the questions in the confidence interval. Here I've taken one question from the past paper of 2002, October-November. Question number 1. Now let's look deeply into the question. The time taken T minutes for a special anti-rust paint to dry was measured for a random sample of 120 painted pieces of metal. The sample mean was 51.2 minutes. And an unbiased estimate of the population variance was 37.4 minutes squared. Determine a 99% confidence interval for the mean drying time. Now we need to look into confidence interval. So what does it mean? If you draw a graph, we have a 99% confidence interval. So we need to find out the lower limit and the upper limit of this confidence interval. So to do that, we have been given certain data. The first thing that is been given is the random sample size n, which is 120. The sample mean is given, that is x bar is given to be 51.2. An estimate of the population variance is given, sigma square is given 37.4, and we need to find out a 99% confidence interval. So let us look into the formula of finding the confidence interval. So the formula says x bar plus or minus z into the root of sigma square by n. So all the other variables are, other data are given over here. Now we need to know into one particular data, which is the z value. So the z value is corresponding to our confidence level. So for that, we have to have a wider knowledge about our graph. The graph says we need 99% confidence interval, and our z value corresponding to this graph in our standard normal distribution graph, this would be negative z and this is positive z. So if you have 99% here, 99% here, but z corresponds to the area to the left of this particular value here. So all the area to the left of 99%, which means the value of z is 99 plus the other small area here, which is half a percentage here, half a percentage here, so a total of a 99.5%. Right, so what we need to do is z will be phi inverse of 0.995, which is a 99.5%. Which is equal to plus or minus 2.576. So here we got the value of z. Now let's substitute all the values that we have into the formula. So 51.2 plus or minus 2.576 times the root of 37.4 over 120. Calculating this, you will get 49.761A, etc. to 52.63 etc., which is approximately 49.8 to 52.6 in 3SF. That is the upper limit and lower limit of your confidence interval with a level of 99%. So hope you have understood this method. The only extra thing that we are calculating over here is the z-value, which is quite easy if you know the graph, the technical part of the graph. We are concerned about the 99% which is in the middle, but as you know, the value from your z table is to the left of 99%, to the left of this particular value z, so that area corresponds to that. So to the left of means it is including this 99 plus this half. That is why we take 0.995 that to represent the exact value of z. All right, let's now go to the next question. The next question says that the result of a memory test is known to be normally distributed with mean mu and standard deviation 1.9. It is required to have a 95% confidence interval for mu with a total width of less than 2.0. Find the least possible number of tests needed to achieve this. So this is a bit indirect question. They are not asking you to find the confidence interval, but the confidence interval is given to you in the form of width, and they are asking you to find the least number of tests required. In the sense, they're asking you to find the sample size. So we have been given here the standard deviation 1.9, your alpha percentage, which is 95, and your width has been given 2.0. Now, what is to be found out is the least number of possible tests required. The other data that is given is this particular sentence. Now, the clue is in this sentence. If you are able to convert this sentence into a mathematical sentence, you are half done. Now let's see what is the meaning of that. Width is less than 2.0. What is width? The formula for width is 2z times root of sigma square over n. That is given to be less than 2.0. So z, the value of z is, again, if you know the graph, this is 95%. So here you will have a total of 5% outside, which means it is 2.5, 2.5. So a total of 95 plus 2.5, which is 97.5%. So z is equal to phi inverse of 0.975, which is plus or minus 1.960. All right, so we have now all the remaining other values. So 2 times 1.960 times 1.9 over the root n is less than 2.0. So you can multiply all these values, cross multiply with this root n, and then similarly you can find what the value of n. So that brings down to, or what you can do over here is you can just cancel off the 2 from both the sides. We have a 2 here and a 2 here. So you can cancel off this 2 on both sides. So what do we have here is 1.960 times 1.9 by the root of n is less than 1. So Once you cross multiply, you get n is greater than 1.96 times 1.9, which is 3.724. So n is greater than square of it, which is 13.86. So the least possible value, which is a whole number greater than 13.8986, will be 14, and hence the least number of tests needed is 14. Now let's move on to this question. Here the question says, a survey of a random sample of n people found that 61 of them read the reported newspaper. A symmetric confidence interval for the true population proportion P who read the reporter is 0.1993 to 0.2887. Find the midpoint of this confidence interval and use this to find the value of n. So basically the question given over here has got both the limits, the lower limit and the upper limit. So let's think that this is the population proportion P here, and we have a lower limit here 0.1993 and an upper limit of 0.2887. Now this is keyword in this question saying symmetric confidence interval, which means it is symmetric. The confidence interval is symmetric. So they are leading us to the answer by asking us to find the midpoint of this interval and use this to find the value of n. So to find the midpoint of this, what we do is, midpoint will be adding up both the limits and then dividing it by 2. That will give you 0.244. So you can imagine that if you divide, or if you find the midpoint of a confidence interval, which is symmetric, and the midpoint will be representing P. So in a way, the population proportion P is 0.244. Now using this P, how will you find the value of n? For that you need to know what is the definition of proportion. So proportion is, we can say that the number of people who read the reported newspaper out of the entire population. That's the meaning of proportion. A part of people who read are favorable to what we are talking about. So 61 over the total population will give you the proportion. Now we know what is P. P is 0.244, and which is equal to 61 over n. So hence what is n? So n is found to be 250. So that's the first part. Now coming on to the second part, find the confidence level of this confidence interval. So we have been given the lower limit to the upper limit, and we know that this occupies this much area, and indirectly they are asking you what is this, or what percentage is that area, or what is the confidence level of this confidence interval. So for that we need to know which is the letter that is corresponding to alpha. From alpha, when we are finding out the confidence interval, from alpha percentage we convert this to z first. So here the same thing is going on. So when alpha was given, we found z. Using z we got to the interval. Now interval is given. Using this interval, we have to find out z, and from z we go back to alpha. So this is the method. Now think about how to reach z using our confidence interval. There are actually three ways you can do that. Either you can use the lower limit and get to z, or you can use upper limit and get to z, or you can use width and get to z. In all the three formula you have z. So I'm going to use width formula. Width equals 2z times root of pq over n. So width is actually upper limit minus lower limit. P is the proportion. We have it here, 0.244 or 61 over 250. Q is 1 minus that. N is the total, which is 250, and hence you can get the value of z. So let us substitute the values. The width is 0.0894, which is equal to 2 times z under the root of 61 over 250 times 1 minus 61 over 250, the whole divided by 250, which gives you. Right, calculating this, you will get the z value as 1.646 to rounded to 3 dp. So I've got the value of z. Now let's come into the graph. We have the confidence interval, lower limit starting from here to here. This is negative z to positive z. In terms of your standard normal distribution, this will be 0. Now I've got this value as 1.646. So if this value is 1.646, this value, what area will it correspond to? Or what will be the area up until this point? How do you get that? So for that, we have to use our phi of z. And we know that phi of z is the area or the probability up till the value z. So phi of z is phi of 1.646. You get the value from the table. So we get from the table 0.9501, which means the area up until this value, right from the lowermost point or negative infinity, is around 95%. To be precise, 95.01%. But I don't want the whole thing. I just want only from this point till this point, which means I have to remove this point. So how can I do that? How will I get this part? This part is actually the same as this part over here. How do you get that? That is 1 minus this. So 1 minus 0.9501, this value is representing this space here, and that space is same as this space here. All right, so from the total area, if you subtract this one, you get it. So which means your alpha is, the total area is this one, so 0.9501. From that, if you subtract the smaller area, which is your, if I shade this whole thing, I want the unshaded area is 1 minus that. So 1 minus 0.9501. This will be alpha. So from the total area, 95%, I am subtracting the small area which is outside the limit. This is what will be my alpha. Let's calculate and see what the value is. And you can see that the value is 0.9002, which is approximately 90%. So our alpha is 90%. So you can write this as 90.02%. And if they ask you to round it to the nearest whole number, it is 90%. And that is your confidence level. Which is your 90%. So please take a note of the graph, what we have done. When you take phi of z, you're getting the entire area right from here goes down to the negative infinity. Now we don't need the whole part, we just need only the limit starting from the lower limit. So the area starting from the lower limit right up until the upper limit. So in order to remove this area, in order to remove this area, what we do is from the whole area, from the total probability, we subtract the area that is given. You will get this unshaded region. And unshaded region here is same as this region because it's a normal curve. It's a bell-shaped symmetrical curve. So the total area, if you subtract the red region, we get the confidence level, which is your alpha percentage. Hope you have received this concept. Whenever you get this type of question, try to use graph, which will be more easy rather than learning the formula which is used over here. Thank you.